How are we doing, everybody?
Good.
You ready?
Yes.
So, we have been talking for about first of all, let me introduce our guests. So, how would you like them to refer to you?
Mr. B's fine.
Mr. B. So, this is Mr. B. He is our representative from the Foss Company who does all the wonderful activities with our science curriculum. He's the one that actually teaches all the teachers how to do the activities before we do them with you. So,
I saw you.
He did. He's a wonderful teacher. I've really built up your, we have really high expectations for you.
Great.
Okay, so we've been talking for about 2 weeks now about circuits, right?
Yes.
Who can tell me something about a circuit?
There's an open circuit and a closed circuit.
Okay, there's an open circuit and a closed circuit. What does an open circuit have that a closed circuit does not?
A gap.
A gap, or an
Space in between.
gap, space, opening, perfect. Tell me something else about a circuit.
If the circuit is closed, then the power will run through, and if the circuit is open, then the power, it will run, then it'll stop.
Love it. Tell me something else.
It had, if you connect the strings and the wires good, the motor's going to start running.
Okay, so when we did the activities with the wires, what's one way that, because we did a couple different investigations where we made a motor run, what's one of the power sources we used to make the motor run?
We connected one to the back and connected one to the front
Of what?
of the battery.
Or what else do we call it?
The D cell.
The D cell. Perfect. What's another way we made a motor run? We used the dry cell and
The solar panel.
the solar panel. Perfect. So the dry cell and the solar panel were, what part of the circuit were they? They were we got posters around the room, you can cheat. The dry cell, the solar panel. What part of the circuit were they?
Energy source.
The energy source. Perfect. Okay. Now yesterday, we learned about a certain type of circuit. What type of circuit did we learn about yesterday?
Parallel circuit?
Not yet. That's today. You're jumping the gun on me. What did we learn about yesterday?
Series circuit.
A series circuit. Perfect. We took a dry cell and some wires and 2 light bulbs and we hooked them all together and we made the light bulbs light up, right?
Mm-hmm.
But what did we notice about the light bulbs?
They're very dim.
They're very dim. It's very weak. What did we do to that circuit to make those light bulbs brighter?
We added another battery.
We added another battery. Or we added another
D cell.
D cell. Okay, perfect. That's what we had. Okay, so we added another dry cell.
But my groups, it didn't work because when we was trying to do it, the battery wasn't right. It wasn't the right way.
Yeah, so then we talked about how you position the batteries in your circuit, right? Which end of the battery does the electricity flow out of?
The top.
Plus. Minus.
Okay, so we were 50-50, right? So what?
Plus.
Let me see. Show of hands. Who says it's the negative end? Who says it's the positive end? A plus for you. Okay. The negative end. So the electricity flows. You have your plus and your minus. The electricity is flowing out of the negative end through your circuit back to the positive end. So if I wanted to put in another dry cell here, how would I have to have it set up? What would have to be here next to the negative terminal on the battery in order for this to work properly? Would I have to put it in? So this is, okay, so this is a dry cell, but I'm not going to tell you which end the little bump is on, which is the positive, which is the negative. What has to go here?
The plus sign?
Yeah, we're going to put the positive here, so then the electricity can flow all the way through, out of the negative, around through the circuit, into the positive, and then when it goes through the 2 dry cells, we're going back from the negative to the positive, right? Excellent. So, look at the light bulbs up here. bright, aren't they?
Yes.
Now imagine if we had to try and power all these. So we've got 2, 4, 6, 8, 10, 12, 14, 16. There's a lot of light bulbs.
18.
Do you think we would really want to power all of those with a whole bunch of dry cell batteries? That wouldn't work, right? That wouldn't work. We wouldn't want to do that. So, open up your notebook for me.
I gotta go get my notebook. Exactly.
Open up your notebook. Turn to your next clean page for me.
I have a key.
This is the 2-pin. I have Trinity's and I have. One of these yours?
There you go. There you go.
Nope. These yours? That's yours? This is yours? Okay. Go check your classroom maybe? Did you take your home last night? Okay. Yes. Do a nice sheet of paper when we find your notebook, we'll get you all squared away. Okay. So before we look at our focus question, here is a little diagram of a circuit, right? Now, this is an okay circuit, but ours were much better circuits. Because what did we have in our circuits that they didn't have here?
The switch.
The switch. We were next level yesterday, all right? We were using the switch.
I know another thing they didn't have.
What?
They didn't have another battery.
Well, that was in the second part, right? When we first made the circuit, we just used
One battery.
the dry cell, the light bulbs.
But it didn't work.
Right. Okay, so here we have the negative, and here we have the positive. I need someone who can come up here and show me how is the electricity flowing through this circuit. Ramonte, do you think you can do it?
Yes, I do.
Okay, I'm going to come up and I'm going to pick the highlighter tool. Okay, oh, that's a little too thick. Alright, can you come up here and show me where's the electricity going to start? How's it going to flow through that circuit? And where's it going to end up?
Yes. So where does it start and where it's gonna?
Yep. Follow the circuit for it. Where does it start? On the circuit.
So where is it gonna start? So it will start from right here.
Where does the electricity flow out of? The positive or the negative end?
The positive. No, the negative.
The negative end. There we go. I knew you had it. All right. So show me. Out of the negative. Up and around. Then what?
Keep going.
Gets to the light bulb. Then what does it do?
Keep going.
No.
Well, it's got to go
They gotta.
through the. If you need some help, ask your partner. Ask your partner for some help. He's got the first part down. The electricity comes out of the negative end of the battery. It comes around to the light bulb. Now what's going to happen, Keon?
It's gonna go through here, and then it's going to touch this. It's going to make this light bulb light up. Then it's going to keep the energy going to keep running and make this bulb light up, and then it's going to close the circuit.
Keon, I love it. There you go. Who agrees? Is that how it works? Yes, we got it. Okay. So we reviewed our circuits. Oh, is this our? Oh, okay. In the top of your paper, in our margin, I want you to write right here, building parallel circuits.
On the top.
Yep, across the top, in our margin, building parallel circuits. No, I love this lesson today because there's a lot of opportunity for you guys to do some exploring. Okay, you're going to have a lot of time to be handling things, doing things, and kind of figuring things out on your own. Now, I'm excited about this group because in all three of the classes yesterday that tried to make series circuits, everybody figured it out. But this group, Nasir yesterday, actually built a parallel circuit. He didn't know he built a parallel circuit. It was an accident, but he figured it out. So everybody yesterday, when I handed this stuff and said go, Nasir's the only one that figured out how to do a parallel circuit. So I'm interested to see if he can do it again today, or if he just lucked into it yesterday.
By myself?
No, in your group. All right, so here is our focus question for today. If we want to make the light bulbs brighter, we added an extra dry cell. But how can we make 2 bulbs bright with just 1 D cell? How can we do that? How could we make the light bulbs? You're going to get a chance to figure it out. So write this down. This is your focus question.
So if
We already wrote this down.
no, we didn't.
Oh no,
One
this
D-cell.
one.
The focus question from yesterday was very similar, but
But it
it's little
said with 2 B's.
right. So write down your focus question. So as you're writing that down, I want you to think to yourself, yesterday we did series circuits. There's one path for the electricity to flow, so it makes it a series circuit. Today we're going to try and make a parallel circuit. By the end of the day, everyone should know how to make a parallel circuit. I think we can do it. Now, once you write down your focus question, I want you to skip, I don't know, 5 or 6 lines maybe. Skip 5 or 6 lines, and then draw a little line across your paper. Because once you figure out how to make a parallel circuit, and I know everybody's going to do it, you're going to use this section of your notebook to draw the picture. You're going to show me what you did to make that circuit.
So not yet.
What do you mean? Well, you can't draw it yet because we didn't do it yet. What's wrong?
Top of the bottom.
Below the line. Below the line on the bottom of your page.
I know what to do. I wrote that way.
Okay. Everybody got this?
Yeah.
So here is the 2 bulb challenge. Each group is going to get the circuit board. You are going to get 2 bulbs. You're going to get wires. What's wrong? What about them?
The battery popping out.
No, okay, I'll fix it. Okay. So we have the circuit base, your D cell, your light bulb holders, and some wire. And you are going to make for me a circuit with 1 dry cell that makes these light bulbs light up right. Can we do it? I think we can. Just like yesterday, you don't need the motor. So leave the motor in the bag, you don't need it.
Okay.
I feel like I want to challenge you, but I'm going to say we won't worry about the switch today. Okay, we did the switch yesterday. I want to see if you can do the parallel circuit first, and then we can worry about the switch. All right? So I need Krishan and Caden and Jaden and Jeremiah.
Go get some
Gentlemen?
Oh. Can we go ahead and get started?
All right. So you have your materials. You have the instructions. You don't need the switch. I can't tell you. I don't know how many you need. You have a whole bunch. If you need some, I will get you some more. Okay?
So I like how you're checking all of the contact points. What do we need to make sure is touching?
All of the wires.
All the wires. What part of the wire?
The part where it should light them up.
Oh. Battery doesn't look Well, I think we're gonna connect it like. I think we're just gonna connect it to one, like to something like this or something. And then
That's not gonna work.
it's just
Okay, let's see what she's gonna do here. Tell them what you're gonna do and see what they think about that first.
I'm gonna try to do the same thing like I did with this one.
So basically, put 2 in here.
And I remember how I see it. Did he
Say
put
it in English.
one in here? Then he put another one in here.
That's what she's been trying to do.
All right, and how are we gonna know? We're looking for the light to be lit brightly, right?
It's not working.
No.
Here, put it in a different connector.
So
Okay, so we had made the whole circuit and hooked the wires up to the screen.
can we try to do it with another one? Another light bulb?
Okay, I want to see the test. Let's see the test. Let's see if it works. Nice.
We did it again.
We
All right, so you guys got 2. You think you'd figure out a third way to do it?
What we did is connected this to this, and then we put this wire to this wire. So we did this, like we connected it to the body for the energy to flow up here to that, and then come up here. And then we connected this to this.
Then it come around.
Yeah, then we come around and then it hit to this, and then
turn. And it flows back into the battery.
so the battery is like flowing energy into the.
Lit, exactly. All right, somebody trace with your finger and show me the pathway. Can somebody show me the pathway that the energy's taking from the battery to this and then back to the battery?
It's going from
Coming out the negative side
to the battery.
and going back to the positive. Well, no, it's not coming out of the positive side. How's it going to come out on this one?
Wait, so it's coming from here.
The negative side right here.
Here.
Hang on. All right. So you showed me this one, right? It's here, and then it came back here. All right, show me this one.
Going here to here.
Exactly. So you got 2 different ways that the energy's traveling. And you got some bright bulbs there. Excellent. Excellent. I like the way you guys work together too.
So basically, 2 wires went here and 2 wires went here. There's more energy, so now both of the bulbs are lit bright.
Because it goes from here to here to here,
Then
and then
more
it goes
energy.
back in here to here.
And then it keeps going around and it lights them up right
What do you think? Just
until
It
they
just
go
got
out.
dim.
Until they go out.
It's because the wires are becoming disconnected. Oh, this one is brighter than this one. Oh, look at
How
that.
would you do that?
It's because it's not in there all the way. There.
Good job.
Fixed it.
That's better.
Right now, we have one pathway that everything's.
Do one of the bulbs and see what happens.
I know what happens.
What?
They're both gonna go out.
Other way. Screw the other way.
Right, so
They're both gonna go out.
it's coming to the same side.
Because there's energy going to this one and there's still energy going to this one, but once this is connected to the D cell too, and then
Yeah, but
power
this
is still
one-
going to it.
this one-
If they were connected, Robert, they would both go out.
Both of these are gonna be out. The reason why this one went out and this one isn't because because these 2 are connected to its own, which gives it its own battery source. But this one hasn't been.
So the electricity coming out of the negative end has multiple
It's going
paths.
multiple
If
paths.
this one is out, it's not going to go down here, but it can go through this way. If this one's
Just gonna
plugged,
keep
if this
going
one's
around
in,
this way.
it can
and keep
choose. It
going
can
around.
go all the way around and go over one. What happens if you unscrew that one? They both going
It's
to go
gonna go
out?
out. Nope, that one's gonna stay on.
Because there are what?
Multiple paths.
About to come out.
Love it. Say those words I like to hear. You figured out a third way? Did you guys get it? Because you guys were pretty far ahead. You guys were doing a really good job.
They got it. They got
Did
it.
they get a third way?
Oh, they got 2 ways.
They got 2 ways, okay. And I think everybody got 2 ways. And I actually had 2 groups who started trying to work on doing it with a switch. So that's awesome.
It wasn't working.
Wasn't
It
quite-
wasn't working for
That's
us.
okay.
We almost did it.
Mr.
3
Shannon,
ways.
we can, we'll start to draw some of those up.
Yes, yep.
Okay.
All right, so I have 2 sides here. I think I want somebody from that group. I need a volunteer from All right, Jeremy.
She's hot.
You want to do a sense-making circle with our notebooks?
Sure.
So they can.
Yeah.
All right. So what we're going to do is we're going to make a sense-making circle. We've been seated for a while. So what we're going to do is we're going to work around the screen here. You're going to bring your notebooks up. So as you learn something new from someone else, you can go back into your drawing and you can add, because we want to make sure that your drawing represents your thinking and what's happening in the system. Okay? So everybody needs their notebook, a pencil, and then we'll just kind of make a circle right here, all facing the board, and we'll make sense of what's happening here. All right, go ahead and start drawing what you
So this is
observe.
what we did. We draw the battery,
The what?
the D cells.
Thank you.
And so we had the springs coming out, and so we had the wires coming from here and from here, and then we had the springs from the first light bulb. So and then we had from these the same springs to this spring, and then it powered up both of the light bulbs. Then powered up both of the light bulbs.
Perfect. Okay. I think most of the groups figured this out. This was the second way they figured it out. Okay. So, but this is perfect. Okay. If we're at the negative terminal and we come out and our electricity has multiple paths. There's more than one way to go, right? We come out here, we can either go through the first bulb or we can go through the second bulb.
How do you think we can show that in our picture? So we're showing our thinking. What could we add to
You could
that?
add some arrows.
Add some arrows. How many of you have arrows in your notebook drawing? Showing the energy, which way it's going. If not, get those arrows in there to show which way your energy is going.
And then
You have your
go
terminals on
this way
your plus and your minus.
or this way.
Coming out of the minus, right? So it's going to go this way.
You're just trying to boss it around.
Here's your circuit.
Yeah, going that way. But how about in this one here then? Which way's the energy going?
Which is the negative, which is the positive side of your terminal of your key cell?
And then it goes back through. And it goes back through. Then it goes around all again.
The positive. Flow up through
No, it can never be.
this light bulb.
The series circuit. Remember you have, so can you adjust, can you, here.
Look, we only have one path. The dry cell, going to this light bulb, come around.
Get fixed, remember it's fixable, drawings are fixable.
Right? You did one where the dry cell is in the middle, so there's the light bulb, light
This would
bulb.
be the series circuit.
The dry cell, the light bulb, the light bulb.
But don't erase this. Don't erase this. Yeah, you can erase all that. Just try not to erase that line, that small line.
Draw this one, or are you trying to draw?
I already drew this history.
Okay, so you're just adding your labels. Good man.
What happens when we get here? What happens to that current?
It goes to the side.
Half of it goes that way and half of it goes this way.
Agree or disagree with that?
Agreed.
So half of it goes this way, half of it goes this way. And then what happens when it comes back down here?
They both come down and then they're together.
Then they're together. Okay?
It takes some getting used to.
Yes, it does.
That's the hand. Yeah, I really struggle.
All right, so I gotta go back to.
So what is that? That's your, okay. Perfect. Okay. Okay. So let's take a look at what Keon did. What's the difference between a series circuit and a parallel circuit?
A series has two separate pathways. I mean, that's a parallel.
A parallel, okay? So a series circuit has one pathway, and a parallel circuit has multiple pathways. So if we come out of the D cell, we come around here, we have more than one place to go. If we come out of here, and we follow it up through this light bulb, then we get to the second light bulb. How many paths do we have?
One.
Just one. So what did you make? This is a series circuit. Okay, it's a well done series circuit, but it is a series circuit, okay? So can we have somebody else come up and show us, can you show us a parallel circuit? How did your group make a parallel circuit? And what is that?
A D cell.
Okay. It's really hard to write small. It's just, there's fine.
That's why that you gotta have that B in there, right? Big.
Okay? And now what did you do? Remember, multiple paths.
We took the light bulb, connected it to the wires, and it lit up one like that.
Okay?
Then we made another one over here, light up like that. And there's two pathways.
Okay?
What should we add to this picture?
Arrows.
For what?
What an energy going?
For the circuit, right? For the current. Good job. Good job.
Okay? Can Caden, wonderful job, A+. Could somebody else come up and show us? And I think we had, what did we have, green?
Yeah, let's use green.
We'll use green. Can somebody else come up and show us how, I got somebody from that group and that group, and I didn't have anybody from this group. I need somebody from this group. Who can come up here and put the arrows?
Rock, paper, scissors. Rock, paper, scissors. Rock, paper, scissors.
There you go. Ramonte, go get him, buddy.
All right. Ramonte, instead of using a triangle, just give me a little pointer there that just kind of shows us which way it is. Yeah, just make, right on the wire.
Here's your D cell, okay? Your positive and your negative. So where's the electricity going to come out?
For the positive and negative. Okay. So the positive
Who's in
starts at
where?
the negative. Starts at the
There you
negative.
go.
There you go.
All right, good man.
So it's gonna come from right. Oh. Good to the right.
Just right on there.
Okay, so this will be there. Like, do we highlight it?
No, so it's going to come out this way?
Uh-huh.
So just do this.
Okay.
Okay, and then once it comes up through here, through the bulb, what's it going to do?
Let's go light this bulb up.
Okay.
And then keep going.
So give me another arrow.
Keep going through here. Then it's going to go through this battery all the way through there. And it's going to light up this bulb right here.
Okay, so give me.
the pointer part, the skinny part, the pointed edge is what points, it shows the direction that it's going in, on your arrows. You know what I'm saying?
Okay.
Oh, it's done.
Ramonte said something interesting, and I just want to ask what you think about this. He says when the energy comes back to the positive terminal of the D cell, that it flows through here and then back around. Do you agree with that or disagree with that?
I agree.
Agree? Why do you agree?
Because it's supposed to go this way, and then make this light bulb light up, and then go.
So you think it comes through here and this is connected inside the D cell? No? Why do you disagree?
Because it should, half of it should go up that way and half of it should go down that way.
Okay.
I was gonna say
You agree?
I agree with John,
John? Okay.
because half of it should split up and then they reconnect, then they split up and they reconnect.
All right. So what's happening here? What were you going to say?
I say it's right because some it might when it gets here, when it gets to there, they split this way.
Okay. So here's a question. Are D cells always good?
No.
No, they run out of energy, right?
And then you get the back.
So actually inside the D cell, so on the negative terminal, that's where the good energy is. When it comes back around, it stays in the positive terminal. It's used. So it does not flow through. Okay, it does not flow through. I know you would think it should, right?
Because I always thought the D cells would had acid in everywhere, and once they I didn't know there was like a divider in there to make once the energy comes through, it just stops right there.
As far as we know. We'll have to research that on the internet.
You know what? I don't think I did it with this class because when we watched it in the other class, a lot of it was like more high school. But there's a brain pop video that talks about how a battery works. And like I said, it was really high, so we didn't watch it in every class. But I'll show it to you because they actually show you like what the inside of a battery looks like and how the electricity flows. So we'll use it more for the pictures than the diagrams, okay? So, Mr. B, this is about as far as I got with the other two classes.
All right.
And I don't want to get like wildly ahead of them. So if there was a ELA thing you wanted to get to, we can do that. But that's kind of as far as our science lesson got with the other groups.
So we're going to kind of summarize today what you learned. We learned about series and parallel circuits, right?
Yes.
So let's look at these sentences and let's see if we can figure out which words belong in the blank. So let's look at this first sentence. In a blank circuit, each bulb has its own pathway to and from the blank. So in what type of circuit? In what type of circuit does each light bulb have its own pathway? Parallel circuit. Do you agree or disagree? Agree. Why do we agree?
Because parallel circuits, they split. Like number 2. So it goes from one part of the battery, splits up, and then it stays lit.
Alright, so we can have more than one pathway, right? In a parallel. And where does the energy come from?
The D cell.
The D cell. Alright? Could we put a solar cell on this and do the same thing?
Kind of.
There's another project for you. In a blank circuit, bulbs share a pathway to and from the energy source. Which one is that, class?
Series.
Series. Series. So they share. You remember that the S in series and the word share starts with S?
Yeah.
Share and series, okay? All right. So we're going to do a compare and contrast diagram here. Of course, what did I do with my markers? There. All right, so you have a sheet on your paper. Please put your name on the top of that page if you haven't done so already. You gonna put your name on this paper, please? Put your name on the paper. Excellent. All right, so at the top of the page you see two lines. One's called about and one's called point. So what was today's and yesterday's lessons about? What did you learn about?
We learned about the different types of circuits.
Different types of circuits.
There you go.
So after about, we're just going to write types
There you go. The about. Types
of circuits. What was the point? What were the types of circuits that we learned about?
We learned about the parallel circuit and the series circuit.
You agree? Anybody disagree? All right, so our point here is series and parallel. Under that you see a question that says, how are they alike? So I'm going to model this because I'm going to have you work in partners to fill in this box. So how are these types of circuits, series and parallel, alike? Well, one way they're alike is both have an energy source. And what is that energy source? In this case, what is it, class?
D-cell.
D-cell. I really like how you're using that word D-cell. The beginning of the lesson, I heard some batteries being used, but here at the end of the lesson, I'm hearing D-cell being used.
Dry cell.
A dry cell, perfect. Now, what I want you and your partner to do for the next 2 minutes is to think about both of those series and parallel circuits and what do they have in common? How are they similar? How are they alike? If you need to work in a group of 3 because there's an odd number, work in a group of 3. And just go ahead and jot down as much as you can about how those two circuits are the same. What else do they have in common?
Write that one down. What did both of them have? Yeah, they have something that was being powered, something that used the power. Okay, that's good.
Allow current to flow.
What part of the D cell? The negative terminal of the D cell to the positive terminal of the D cell. Very good.
Have a flow.
Yeah, what's that flow called? A current.
Both have an energy source, they're circuits, and they have wires.
And how does the current flow?
From the negative
How do you spell current?
In both of them, right?
C-U-R-R-N-E-T.
Circle up.
Do we have a... Let's just say one thing, and I'm going to go around the room, and you're going to snap out one thing that both had in common that you talked about in your partner. What is something that they both have in common? Series and parallel circuits.
Power.
Power. Good? All right.
Energy.
What's that?
Energy.
Energy. Good?
Yeah.
All right. Where's that energy and the power come from?
D-cell.
The D cell, right? What did you
Only
find?
one reporter, gentlemen.
Wires. Got that? All right.
They both
What'd you
have a
find?
flow of current.
Both have a flow of current. If you do not have something in your notebook that you hear, you should add that to your notebook, to your page, to your box. So they both have a flow of current. Can someone add to that information about the flow of current?
I can.
What else can you tell me about the current?
One way of current.
One way. What do you mean by one way of current?
There's only one way that they had to go.
And can you tell me about that? A little more about that.
You gotta go the negative way, not the the negative way, not the other way.
From the negative
To
the positive.
positive, yeah, positive.
Do you know what these ends are called? They're
Yeah.
called what?
Wait, no.
Anybody know what we call negative and positive?
Yeah.
Listen, so you know what the word is. Terminals. Say that.
Oh,
Terminals. So the negative terminal to the positive terminal. All right. That happens in both. Now look below. There's a question below the box that says, how are they different? So in this first box here, on the left-hand side, we're going to write the word series. And on the right-hand side, what do you think we're going to write? Parallel.
Get my name.
No. Yes.
What can you tell me about the path of the current? How is the path of the current in a series circuit different than the path of a current in the parallel circuit? Yep, so put that on there. Make a little...
Make the box.
Make the box. I'm sorry, I should have said that. How is the path different now? What's the path like in a series? How is it different in a parallel?
In the series, there's only one path. In the parallel, there's one.
Very good. So next to the word path, underneath series, we're going to say there is one. And in parallel, there are more than one. So we say in a series circuit, because it starts with an S, that the light bulbs, they share the energy. Okay? What can we say about the light bulb?
Make another box.
Yep, make another box. What can we say about the light bulb? What happens to the light bulbs in a series circuit?
How do they look?
They light up. They light up, but how do they light up?
With one path? With one path.
Okay, but how, when you look at the light bulb, how would you describe how it's lit?
Lighting up.
If it's lit, like if it's
I know why you would see light.
so yeah, and if you have two batteries, it will light up like real bright. If you have one battery, it'll light up like.
It will light up bright.
What's our word when it's very little?
Bright.
Dim.
Dim. We found that in a series circuit, that the light bulb was dim. And how is that different from the light bulb in a parallel circuit? How did we describe those light bulbs?
Bright.
Class? Right. Now there's one more thing that we need to remember.
I feel special.
When we take a bulb away, what happens when we take
What does it say?
when we take a bulb away? We take a bulb out.
It stopped lighting up.
And on series perfect, it
I want
doesn't.
to let her talk, okay?
Stops lighting up, but the other one stays.
In which one does it stop the light?
One next to our school.
Okay, but which circuit? The series or the parallel? When we take a bulb out, all the lights go out. In the series, excellent. So in the series, lights
Go out.
go out. And in a parallel, what happens?
Once that you take one out, the other one will stay on.
Remaining lights stay on.
Actually, she didn't go
All right. So do we now know how the series circuits and parallel circuits are alike? And how can we tell if they are different?
By doing these experiments on the thing.
Yep, doing the experiments. Now we've got it in writing, right? If I was mean, I would make you take this home and write a 3-page paragraph, 3-page article on series and parallel. Just kidding.
I like that idea.
All right.
Everybody was here.
All right. So any questions today about series and parallel circuits? Feel pretty good? All right.
Everybody.
He said, I know.
Are we good?
Yes,
All right.
thank you very much.
You're very welcome. Great job today, class.